Hello. In case we've never met before, my name is Mr. Marsh, and I have created this series of chemistry videos to teach you everything you need to know for your chemistry course. What's even better than that is I'm going to get you to understand it. I have made a video of what atoms are. If you can't remember what an atom is, let me remind you. Everything in the world is made up of what we scientists call matter. Matter has always been here, and all matter is actually made up of tiny, tiny parts which we cannot cut into smaller parts called atoms. Now think about how many different things there are in the world. You, me, your pet rabbit, the sun, moon, projectors, pens, cars, paper, tables, your hair, rivers, oceans and fish. Just think for a moment. What are they all made of? A fish looks as though it's definitely made of different stuff to paper. So let me ask you a question. If there are so many different types of substance in the world, how many different types of atom do you think there are making up all these different things? Well, the answer is actually only about 100. Yup, just over 100 different types of atoms exist in the known universe. And they are joined together in different ways to make everything in the whole world, in fact, the whole universe. Some substances are made up of only one type of atom. This, for example. This copper pipe. This copper pipe is made up of only one type of atom, copper atoms. There are many millions of copper atoms because if you remember, atoms are very, very small indeed. But the millions upon millions of atoms in this copper pipe are just one type of atom, copper atoms. Substances made up of only one type of atom like this have a special name in chemistry. We call them elements, or to give them their full name, chemical elements. These chemical elements are substances made up of only one type of atom. There are only about 100 of them, if you think about it. Here are some more examples. We've already met copper. Copper is made up of only copper atoms. This is a piece of pure carbon, and carbon is made up of only carbon atoms. This is sulfur, and sulfur only contains sulfur atoms. And here is a very rare one. This is mercury. This is the only liquid metal at room temperature. You probably won't be allowed to handle this where you are, because mercury is very toxic. All of these substances are chemical elements because they are only made up of one type of atom. Most of the substances in the world, take you for example, you are not an element. 99% of your body is made of just 6 elements combined together in different proportions. Most of it is oxygen. If you combine them together in different ways, you could make a banana, for example. So most substances are made up of more than one type of atom. They are made by joining, or in chemistry we call it bonding, more than one type of element together to make them. These don't fit within the definition of element because they're made up of more than one type of atom. And these substances are called compounds, and we will deal with those another time. The chemical elements are displayed on a table called the periodic table of the elements. Now we rarely give it its full name, and we often just shorten its name to the periodic table. If you hear periodic table, we really mean the periodic table of the elements. On the periodic table, you will find all of the different types of atoms, which you can make anything in the whole known universe from. When you look at the periodic table, I would like you to remember that groups go down and periods go across. That is how the periodic table got its name. More on why this is important later. During a chemical reaction, it is the atoms that are rearranging themselves to make different substances. That is chemistry. The ancient Greek philosopher Democritus believed that atoms were the smallest parts of matter and that we couldn't divide up matter any smaller. He was right. During a chemical reaction, it is the atoms that react with one another. But scientists started to question if atoms had anything inside them and started to look to see if atoms had even smaller particles making them up. We made our first real discovery around the early 1900s when John Dalton, J.J. Thomson, Ernest Rutherford and Niels Bohr discovered that atoms were made up of smaller particles. They called these particles subatomic particles because they are smaller than an atom. So they conducted experiments to see where these subatomic particles were found in the atoms and what they were like. Remember how small atoms are? Well, imagine how small the parts of an atom must be. Let's look at what they discovered. We will use the element calcium as our example. Why not? All atoms are actually made of smaller particles. One of them is called the proton, one is called the neutron, and the other the electron. These particles are found in all atoms. How many of them depends on which atom type they belong to. You can see here that the electrons are constantly moving around this bit in the middle called the nucleus. These electrons going around the nucleus can only occupy certain areas around it. These look like they're arranged in layers, don't they? In fact, they are called shells because they are moving around in 3 dimensions all the time. For your course, you have to remember that the first shell can hold a maximum of 2 electrons and then it's full. The second shell can hold 8 electrons and the third can hold 8 electrons as well. It is the electrons on the outside of the shells which move during a chemical reaction to hold atoms to one another. Let's worry about that in another video. After shell 3, you go on to bigger numbers, but you don't need to know those for GCSE, so just memorize the first 3 shells. In the picture, you can see a tiny, tiny centre, which we call the nucleus. In that nucleus, you will find 2 of the 3 subatomic particles I told you about. They are the proton and the neutron. Sometimes you will hear them being called nucleons because that's where you find them. There are 2 things you need to be able to describe about these particles, and you have to know them off by heart. One of them is called mass. The idea of mass can be quite difficult to explain, as it is what physicists call a fundamental property. But you can think of mass as either how much it will attract itself to other things by gravity. So if you have an object with a lot of mass, there is a lot of attraction by gravitational forces. And so when you come to pick it up, you will notice that it feels heavy. Another way to look at it is how much force does it take to get the thing moving? Something with high mass requires more force to get it moving than something of the same size but with little mass. Anyway, let's look at the particles which have mass, the proton and the neutron. They both have a mass of 1 atomic unit. On the other hand, an electron has almost no mass at all. In fact, it is 1/1836th of the mass of a proton or neutron. That is very little mass indeed. That makes an electron a closer relative to light than it does to particles themselves. In your exam, you can use the phrase negligible or almost zero for the mass of an electron, and the examiner will know what you mean and give you the mark. Now, the other property is that of charge. This is different to mass. If you remember, we said mass made things have a strong gravitational attraction to things, and objects with a lot of mass makes them difficult to move. Charge, however, is a different fundamental property, so you need to think how you can explain the idea of charge. Charge is an invisible property, but I can give something charge and you can see the effect of it. By rubbing this rod with this cloth, I can put charged particles on it. Charge either pushes or pulls on other things which have charge. I've coloured the water here for us to see more clearly. If you see, the rod does not have to touch the stream of coloured water for it to have an effect, because charge is what is known as a non-contact force. It doesn't need to touch an object in order to have an effect on it. It is similar to magnetism, which is another non-contact force, and like magnets, charges can push or pull on one another. With magnetism, you have a north or a south pole, but with charges you have a positive and negative charge. All you have to remember is that opposites attract. But what if something has no charge at all? Well, we say that something is neutral. So positive charges attract negative charges, but repel other positive charges. The same with negative charges. They push other negative charges away from each other, but pull on positive charges. So far, I have told you that protons and neutrons have the mass of one atomic unit, and the mass on an electron is negligible. But what charges do protons, neutrons, and electrons have? Well, let's start with the easy ones to remember. Protons are positive. Remember, P for proton, P for positive. Got it? Good. Neutrons are neutral. If you look at the name neutron, you can see it has part of the word neutral in it. That will help you remember. Electrons, remember those things whizzing around the nucleus in shells? They are negatively charged. They experience a pull from the positive protons in the middle, which stops them flying off away from the atom. To help you, here is a summary table that is well worth learning off by heart. This information is a really common exam question, so by learning this summary table, you can remember everything you need to know about these little particles which make up atoms. In your exam, not only will you be asked to explain things like where protons, neutrons and electrons can be found in an atom and what their relative masses and charges are, you will also be expected to use this, the periodic table of the elements. As you can see, each element has its very own symbol. Some symbols are just a capital letter, like carbon here. And some have two letters, like iron here. Notice that the first letter of these elements are always capital letters. Iron is capital F, lowercase e. It is easy to see the individual elements because each one starts with a capital letter in a chemical formula. It is really important to make sure you use your capital and lowercase letters correctly. If you don't, you can completely change the meaning of what you have written. There is so much information you can get from the periodic table because of the clever way it is arranged. You have to learn how to get all of this information from the table very quickly and easily for your chemistry exam, and I'm going to show you how. If you look more closely at the periodic table, you will see that not only does each element have a name and a symbol, but also two numbers in the box. One number is always bigger and the other smaller than the other one. One of these numbers is called the proton number and the other is called the mass number. The proton number is always the smaller of the numbers and the larger number of the two is always the mass number. Remember it like this. Mass numbers are massive. Now, in some books, The proton number is sometimes called the atomic number, and the mass number is called the nucleon number. I don't mind which one you remember. They mean the same thing, as long as you remember that the proton number is the smaller number and the mass number is always the bigger number. By using both numbers in the box, where you see the symbol for each element, we can work out easily how many protons, neutrons and electrons there are in an atom. And you will have to be able to do this for your exam. If you have a periodic table nearby, take a look at it now. Do you notice something about the pattern of the proton numbers and the order of the chemical elements on the periodic table? I notice that the table is arranged in order of proton number. Each element in the periodic table has a proton number just one bigger than its neighbour. This is not a coincidence. Let's start with the smallest of the two numbers, the proton number, sometimes called the atomic number. The proton number tells you how many protons there are in the atom. Mind blown. It's not the hardest thing to remember, is it? That never changes for an element. For example, oxygen atoms always have 8 protons in their nucleus. It is one of the definitions of what makes oxygen oxygen. So the proton number of oxygen is 8. Okay, we now know that we can get the number of protons from the proton number. Not really rocket science yet, is it? Do you think it can tell us anything else? Well, what about the electrons? They are oppositely charged to a proton, if you remember. Protons and electrons are oppositely charged. So in an unreacted atom, the number of protons and electrons are always matched. They are the same. So look at the symbol for oxygen again. We can see that oxygen has 8 protons, so it will also have 8 electrons. In fact, all oxygen atoms will always have 8 protons and 8 electrons. Once they had reacted in a chemical reaction, that number of electrons sometimes changes. But we will deal with that another time. For now, you only need to learn that the number of electrons will always be the same as the number of protons, which we get by looking at the proton number. Let's look at a few more until you get the hang of it. Starting at the top of the table, hydrogen has a proton number of 1. So it has 1 proton, and therefore how many electrons? 1, because the number of protons and electrons are always the same as one another in an atom. Helium. Helium has a proton number of 2. So it has 2 protons, and because it has 2 protons, we must also have 2 electrons as well. This works for every single element on the table. Look at barium. Barium has a proton number of 56. How many protons does it have? All barium atoms must have 56 protons. If it has 56 protons, how many electrons must it have? It must have 56 electrons. They will always be the same as one another. Now let's look at the other number you see in the boxes. Remember, the mass number is always the bigger number. So it's the massive number. Mass numbers are massive. I mean, compared to the proton number, they're bigger. This is called the mass number, or sometimes the nucleon number. It is called the nucleon number because it is the number of particles found in the nucleus. The mass number tells you how many protons and neutrons there are in the nucleus in total. Do you remember which subatomic particles are found in the nucleus? If you remembered correctly, well done. It is the protons and the neutrons. Let's use lithium as our example, and we'll see how good your memory is. If lithium has a proton number of 3, then how many protons does it have? 3, that's right. If the mass number is 7, and the mass number is the number of protons and neutrons, we can quickly work out the number of neutrons there are in an atom of lithium. Can you see how? You need to remember what we just learnt about the proton number. Lithium has a proton number of 3. So it must have 3 protons in its nucleus. It has a mass number of 7, which is the protons and neutrons added together. Can you see that the number of neutrons that an atom of lithium has must be 4? Let me show you why. The mass number for lithium is 7. The proton number for lithium is 3. Since the number of protons and neutrons equals 7 and 3 of them are protons, what must be the rest be? Neutrons. Since 3 add 4 equals 7, the number of neutrons must be 4. This is very easy maths, but very difficult to get right every time. Let's do a few more examples together to make sure we understand. Let's use carbon as our next example. Carbon has a proton number of 6, so it must have 6 protons. Carbon's mass number is 12, showing that when added together, the protons and neutrons equals 12. If 6 of the 12 are protons, then we must have 6 neutrons, because 6 plus 6 equals 12. Can you do it with another element you've not seen before? Sodium has a mass number of 23 and a proton number of 11. If you take 11 away from 23, you get 12. So in sodium, you must have 12 neutrons. Let's combine all of this together to get the whole picture of a sodium atom. Sodium has a proton number of 11, so we must have 11 protons. We have just calculated that it has 12 neutrons, so they go in the nucleus as well. Do you remember what we said about protons and electrons? They must always be the same number as each other. So because we have 11 protons, we must have 11 electrons. Now we can't fit all 11 electrons around the nucleus in a ring. They wouldn't all fit. So let's remember how many electrons each shell can hold. The first shell can hold up to a maximum of 2 electrons. The second shell can hold a maximum of 8 electrons, and the third can hold a maximum of 8 electrons too. We have to start with the innermost shell and use our electrons up as we go. We have 11 electrons to place. Let's see where they go around the nucleus. 2 in the first shell, 8 in the second shell, and we have 1 more electron to place, which we will store in the outermost shell. There you have it, the complete model of the atom using everything you've learnt so far. This is how just 2 numbers contained in each of those little boxes on the periodic table for each element can tell you so much about the structure of each element's atoms. The periodic table is arranged in what looks like a very funny shape. The groups have numbers and so do the periods. A common mistake is that everybody forgets that hydrogen and helium are in period 1. Remember to start counting your periods from the very top of the table. That means that lithium is in group 1, period 2, not group 1, period 1, which some people say by mistake. The groups tell you how many electrons there are in the outer shell of each element. That means that all of the elements in group 1 have 1 electron in their outer shell. Group 2 have 2 electrons in their outer shell. Group 3 have 3, and so on. The periods tell you how many shells there are. So the elements in period 1 are filling their first shell. How many can the first shell around a nucleus hold? 2. How many elements are there in period 1? 2. Coincidence? No, not at all. The groups and periods can be used to work out how many shells and how many electrons there are in the outer shells. Look, sodium is in period 3, group 1. That means that it has 3 shells, and in the third shell, the outermost shell, it has 1 electron. How clever is that? Don't worry too much about the block in the middle, called the D block. This is beyond what you are studying at the moment. Just use the information from the numbered groups and periods which are provided on your table. You will always get a periodic table in the exam, so make sure you use it. So let's recap what we've learnt. You will always get a copy of the periodic table in your exam. Make sure you get all the information you can from it. Firstly, remember that groups go down and periods go across the table. The periodic table has lots of useful information. The symbols always start with a capital letter, so you can tell the elements apart from each other in a chemical formula. The boxes have two numbers in them. One of them is smaller and is the proton number. One of them is larger and called the mass number. The proton number tells us the number of electrons in an atom because they're always the same number as the protons. The mass number is always the bigger of the two numbers in the box and tells us how many protons and neutrons there are in the nucleus. You can subtract the proton number from the mass number to work out the numbers of neutrons in the nucleus of an atom. The group number tells you how many electrons the element has in its outer shell, and the period number tells you how many shells the atom has as well. Do take the time to learn these facts and practice using the numbers on the periodic table for yourself. Thank you for joining me, and I hope to see you next time for the next episode of Mr. Marsh's Chemistry Videos.